Okay, so now let's look at an example of of the work done by a variable force. So when we are going to approach these kinds of problems for work by a variable force, what you want to do is you want to come up with the equation or the function for the force by either using Hooke's law. Hooke's law is for springs. Hooke's law says the force exerted in compressing a spring is equal to some constant called the spring constant multiplied by the distance that you compress the spring. So that's Hooke's law. And the other one that we might want to employ would be Newton's law. And Newton's law of universal gravitation says that the force of gravity by two objects produced by two masses is equal to some constant times those masses, the product of those masses divided by the distance between those two masses squared. And that is Newton's law. Notice the force involves a constant and a distance. It involves other numbers too, but the constant and the distance are also present over here. This is the spring constant. This is the universal gravitation constant. And then we also have Coulomb's law. Coulomb's law is for electrons or electricity. And Coulomb's law says that the force is equal to some constant, and that constant is going to be multiplied by the two charges, Q1 and Q2 are electrical charges, divided by the distance between those electrical charges. So Coulomb's law and Newton's law are very similar to each other. And Hooke's law is for springs. So we have, this is the force of a spring, this is the force of gravity, and this is the electrical force. So what we're going to do is we're going to have to decide which one of these we're going to use to come up with an equation for our force where the independent variable is distance. Okay? So let's take a look at this problem. A force of 5 pounds compresses a 15-inch spring a total of 3 inches. How much work is done in compressing the spring from a length of 10 inches to a length of 6 inches? Well, in this case, we're not talking about weights or electricity. In this case, we're talking about springs. So I think we're going to opt to use Hooke's law. And we're going to use Hooke's law this way. We're going to come up with an equation to represent our force based on the distance that we're compressing the spring. In this case, it says that a 5-pound force. So the force is a 5-pound force, compresses a 15-inch spring a total of 3 inches. So the spring, when the spring is not being compressed, the spring is 15 inches long. And what we're going to do is we're going to compress the spring a total of 3 inches. So from its initial 15-inch length, I am compressing the spring 3 inches from its initial length. And it takes 5 pounds of force to do that. So we don't know the spring constant, but we do know the distance that the spring is being compressed is 3 inches. So that we can find a value for the spring constant, and the value for the spring constant is then 5/3. And that is 5/3 of a pound for every inch. So the spring constant says this spring requires 5/3 of a pound for every inch of compression. So an equation that I can come up with for my force, the force of this spring, is this. Well, I know that the spring constant is 5/3, and if I multiply that, 5/3. If I multiply that by the distance that I compress the spring, because it's 5/3 of a pound for every inch of compression, if I multiply by the 5/3 by the number of inches that I compress the spring, I can calculate the force exerted to compress the spring that distance. All right, so now I have an equation to represent my force, and I use Hooke's law to come up with that equation. And now I can finish the problem. So let's see. By the definition, the work done is going to equal the integral from A to B. Well, here I want to compress the spring from 10 inches to 6 inches. So I'm compressing it from, I'm not compressing it from 10 to 6. Well, if I've already compressed it so that the spring's length is 10. The original length was 15, so I've actually compressed the spring to 10, and then I compressed it an additional, and now the spring's length is 6 inches long. So I've actually compressed the spring. All right, sorry about that. So along the x-axis from A to B. So I'm starting at 10. I've compressed it 10 inches. If this is the x-axis and this is the y-axis, that means initially I am compressing it so that the length is 10. So I'm actually compressing it from 5 on the x-axis, because if this is the x-axis and it goes all the way out to 15, when the spring is 10 inches long, I've actually only compressed the spring 5 inches. So this is what we're talking about. Let me draw a picture here for you. If this is the original length of the spring, 15, and this is 0, first I'm compressing the spring to 10 inches. So I'm compressing the spring to 10 inches, which means I'm moving from 0 all the way over to 5 over here. This would be 5. So when the spring is 10 inches long, the distance that the spring has been compressed is actually only 5 inches. And then I'm compressing it from 10 inches long to 6 inches long. So now the spring is 6 inches long. This is, of course, not drawn to scale. And when the spring is only 6 inches long, I've actually compressed the spring 9 inches. I've compressed it 9 inches. So what I'm actually doing is I'm compressing the spring along the x-axis from x equals 5 to x equals 9. So I'm actually going from 5 to 9. And then what we're going to do now, we're going to plug in the f of x, which is 5/3 x, because the formula is we're integrating from a to b, capital F of x dx, and that's how we're going to get the work. And that means all I have to do is this integration, which is a relatively simple integration. So we're going to get that this is equal to, let's see, 5, 6 x squared from 5 to 9. And then we're going to calculate this. Let's see, we have 5, 6 multiplied by, and then we're going to have 9 squared minus 5 squared, or 81 minus 25. And let's see. So we have the spring and let's see what we get here. This is going to be 5, 6, and then we borrow here. Let's see, we get the work done by this force is 5, 6 times, and then we get a 6, 7, so 5, 56, and that gives us, let's see, we have 2 goes into both of those, right? So 5, 6, 5/3, and 2 goes into that. 28 times, and we get that this is equal to 140 thirds. So the work is 140 over 3, and that is going to be inch pounds.